Angles of elevation or depression. I'm not going to read all this to you. You can read it yourself. One thing that I would say is if you're depressed, you're looking down. Okay, so if you're depressed, you're going to be looking down. And so just think about that as you draw your picture. Angle of depression is if you were normal, you're looking forward, but if you're depressed, you're looking down. Okay, so that's a common mistake that people make, is they don't think about that. All right, angle of depression is going to be underneath the line of sight, or the horizontal line of sight. Okay, and that little caution down there says the same thing. You've got to look at that horizontal line, okay, between the line of sight and the horizontal line. All right, so here are some application problems. When Shelley stands 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. If her eyes are 5.3 feet above the ground, find the height of the flagpole. I really, really think this problem would be difficult without drawing a good picture. Okay, so I am a huge advocate of drawing a good picture here. Okay, so it's going to be a right triangle. Just know that. So let's say Shelley's standing right here, and she's 123 feet from the base of a flagpole. Okay. So there's my flag. There it is. All right. The angle of elevation to the top of the flagpole is 26 degrees 40 minutes. So they're talking about this right here, and the angle of elevation is from horizontal. Okay, from horizontal to that angle right there. Now remember, 40 minutes, if you were going to convert, you'd do 40 over 60, so that's going to be 0.6 repeating. So I've got 26.6 repeating degrees. Okay, I'm going to change it to decimals. It's just easier, I think, to deal with decimals. That's going to be a right angle, so we've got a right triangle. Okay, now the 5.3 feet. If her eyes are 5.3 feet above the ground, find the height of the flagpole. Okay, so Shelley is standing here, but really this is where her head is, because that's where her eyes are. Okay, she's standing here, and she's 5.3 feet above the ground. So you'd have to add that on, I guess. Over here is 5.3 feet. All right. So the kicker is, I think the important part of the problem is, oh no, I just decapitated poor Shelley. The key is you got to notice a right triangle. Okay. So I want to know this number right here. That number isn't technically the height of the flagpole, because there's going to be an extra 5.3 feet on, but we'll deal with that later. Let's just look at that as far as the triangle goes. Okay, we've got an angle, and if you think about SOHCAHTOA, this would be opposite, and this would be adjacent. That's going to be tangent. Tangent is opposite over adjacent. This is a tangent problem, right? That's hard to see. I think that's hard to get without drawing that picture. But I'm going to set this problem up, and I'm going to say tangent 26.6 repeating equals the opposite side, x, over the adjacent side, 123. So when we cross multiply this, x is looking like 123 tangent 26.6 repeating degrees. And how I'm going to enter that on my calculator is I'm going to enter a whole bunch of sixes in there. Okay, I don't like rounding off. Just put in a bunch of sixes, and that'll be like you barely rounded off. All right, so 61.8, let's call that 61.8. X is 61.8 feet. Now that's not the height of the flagpole. The flagpole is that plus this 5.3. Remember, Shelley was 5.3 feet tall. So the height is going to be 61.8 plus 5.3. That's 67.1. The height of the flagpole is 67.1 feet. Okay. Example 4, the length of the shadow of a building, 34.09 meters tall, is 37.62 meters. Find the angle of elevation of the sun. Okay, so you might start with the sun. I know you don't have a whole lot of room here, but make do. Okay, there's a sun shining on a building. Okay, and that building is 34.09 meters. Okay, so the sun shines down and it says there's a shadow. That building has a shadow that is 37.62 meters. And so again, if you think about it, that sun is shining and it's going to be making a triangle. Let's try that again. Okay. We've got this triangle formed. And assuming this is not the Leaning Tower of Pisa, this is a 90-degree angle right there. So we're looking at a 90-degree, a right triangle here, and they want the angle of elevation. So they're looking for this angle right here. Okay, so again, go back to SOHCAHTOA and look at what we have. Okay, we've got the opposite side and the adjacent side. So again, that's tangent. Tangent theta is going to equal opposite over adjacent. We're going to solve this with an inverse tangent. It's not multiplication. Theta equals inverse tangent of whatever that is when you divide. Inverse tangent, 34.09 divided by 37.62, 42.18, okay, 42.18 degrees. That would be that angle theta. That would be the angle of elevation of the sun.